Good morning, with you your math teacher Mrs. Rabab Ahmed for covering lesson 4 in unit 1 Algebra prep 3, which is the study of the polynomial function. Let's move to the slide number 2. Polynomial function. We have two types of the polynomial function. We will study the first type, which is linear function. Also, the linear function divided into types of the polynomial, 0 degree and first degree. The linear function have 2 degrees, 0 degree and first degree. The 0 degree, it's represented by f of x equal b. b is a constant. b is a constant number. This function is represented by a straight line which is parallel to x-axis as we see in our figure. Then we will move to the linear degree with the first degree. It's represented by the polynomial function ax plus b, such that x not equal to 0. For example, f of x equal x plus 1, f of x equal to x minus 3, f of x equals 3x, and is represented by the following graph. Then we will move to the second type of the polynomial function, the quadratic polynomial function. It's a polynomial function of the second degree. It can be represented or written by ax power 2 plus bx plus c. A, b, and c are real numbers and not equal to 0, and represented graphically by the curve as we see. Then we will move to the third slide. We have here an example. Graph each of the following linear function. Number 1, f of x equal 2x minus 3. If you want to graph any polynomial, we will take some numbers and represent it on the graph. When we graph a linear function, it's enough to get 2 ordered pair or 3 to represent the linear function. For example, let x equal negative 1. We will replace any x by negative 1. Take 1, take 0, take 2. As you like, take 2 points to represent the linear function. We have here some examples. Let x equal negative 1. So we have an ordered pair negative 1, negative 5, 1 and negative 1, 2 and 1. We have a table here. Put the point, then represent it on the graph by put the point negative 1 and negative 5, 1 and negative 1, 2 and 1 as we see in the graph. Then we will move to slide number 4. We have a function f of x equal ax, where a belong to r star, which means any number except 0, is represented graphically by a straight line passing through 0 and 0. If we have any function, for example, f of x equal negative half x, any number multiply x except 0, it will be represented by a straight line passing through the origin point. Let's try. We have here points 0, 0, 2, negative 1, negative 4, and 2. To be sure, write any polynomial. For example, f of x equal to x 3x. You will find that any function in the form ax number multiply x, it will be a straight line passing through the origin point. Let's move to slide number 5. We have an example here, f of x equals 2. This function is called a constant function. It's called a constant function that because it didn't change forever. Any number in x were represented by 2. 0, 2, 4, 2, 6, 2, any number on x, its image, it will be 2. So it's called a constant function. For example, 0, it will be 0 and 2. 1, it will be 1 and 2. 2, it will be 2 and 2. And represented by a straight line parallel to x-axis at the point 0, 2. The straight line is above the x-axis, that because the number 2 is positive. If the number is negative, you will find that the line down to the x-axis. Then we will move to slide number 6. Graph the function f of x equal -4. Then complete the following. As we see, f of x equal number, that means it's a constant function. If the number is negative, that means we have a straight line parallel to x-axis, but it will be down to x-axis in the negative. Complete. The degree of the function is 0 degree. Find f of 5, it will be -4. If I asked you f of 2, -4. f of 7, -4. Number 3, find f of 4 plus f of -4, which means -4 plus -4, it will be -8. Find f of -x. Also, it will be -4, that because it's the constant function, she didn't change forever. We will move to slide number 7. We have here another example. Graph each of the following quadratic function. Quadratic function, it will be with the second degree. It will be with the second degree. F of x equals x to the power 2. But here we have an interval which is -3 to 3. That means I will start from -3 to 3. I will substitute -3, it will be 9. -2, it will be 4. -1 to the power 2, it will be 1. 0 to the power 2, it will be 0. 1 to the power 2, 1. 2, it will be 4. 3, it will be 9. Then we will represent each ordered pair on the graph to have the quadratic. We have some notes here. If the coefficient of x power 2 more than 0, the curve is symmetric with respect to y-axis. Number 2, the point 0 and 0 is the point of the vertex of the curve. As we see here, we have a curve with the vertex. Number 3, the minimum value of the function is 0. The minimum value of the function is 0. Now, we will move to slide number 8. We have here another example. F of x equal -x to the power 2. Taking x belong to the interval -3 and 3. F of x equal -x to the power 2. We will replacement the value of x starting from -3. -3, it will be -9. -2, it will be -4, and so on, to have some ordered pair and represent the ordered pair on the graph. We have here also some notes كده. The coefficient of x power 2 smaller than 0. The curve is symmetric with respect to y-axis. Number 2, the point 0 and 0 is the point of the vertex of the curve. It will be also the vertex of the curve. Number 3, the maximum value of the function is 0. Then we will move to slide number 9. Study the following. If the coefficient of x power 2 is positive, then the curve is open upward and the function has a minimum value point. If the function of x power 2, if the coefficient of x power 2 is negative, then the curve is open down and the function has maximum value. Let's move to slide number 10. Graph the function f of x equal x power 2 minus 2x minus 3, taking x belong to -2 and 4. From the graph, find the point of the vertex, the equation of the line of symmetry, the maximum or the minimum value of the function. By the same way, we will take some points from -2 to 4, then find the value of the image of each one to have some ordered pair and represent on the graph. then the vertex it will be 1 and negative 4. The equation of the line of symmetry is x equal 1. It's a straight line parallel to y-axis and passes through the vertex of the curve. The minimum value here of the function is negative 4. As we see, the curve is looking up, so we have a minimum value which is negative 4. Then we will move to slide number 11. We can know the vertex of the curve of the quadratic function without drawing. For example, if we have a function in the form ax power 2 plus bx plus c, the x coordinate of the vertex, can we get the x coordinate by the following rule, negative b over 2a. Where is b? The coefficient of x. Where is a? The coefficient of x power 2. The y coordinate, it's the image of the x coordinate, f of negative b over 2a. We have here an example, مثلا for f of x equal x power 2 plus 2x minus 3, a equal 1, coefficient of x power 2, b equal 2, coefficient of x, c negative 3, the coefficient of, the number in the polynomial. Then we will calculate the value of x, which is negative 1. Then we will find the image of negative 1 to get negative 1 and negative 4, and this ordered pair is the vertex of the curve. That's all, and thank you.